By default, all Swift functions are synchronous, but what does that mean? A synchronous function is one that executes all its work in a simple, straight line on a single thread. Although the function itself can interact with other threads, it can request that work happens elsewhere, for example, the function itself always runs on a single thread. And so we could write some simple code to show us a series of synchronous functions. We could say here, we have function A, which calls function B, and then might have some other code here, or like a counter variable here, for example, its own stuff. And then inside here, we'll also have function B, which calls, say, function C and does some other work here. And then we'll have as well, of course, function C, which will have its own counter variable here, and then its own extra work. So a simple chain of functions. And this approach has a number of advantages, not least that synchronous functions are very easy to think about. When you call function A, it'll carry on doing all its work until its function completes, and then return a value back if it wants to. As part of that work, function A calls function B, and function B calls function C, which we call D, E, F, and so forth, and it doesn't matter. They'll all execute on the same thread and run one by one by one until the work completes. Now internally, this is handled as a function stack. When one function calls another, the system creates what's known as a stack frame to store all data required for that new function. That's things like its local variables, for example. So the stack frame for function A will have its local variable right here. This new stack frame for the next function call gets pushed on top of the previous stack frame, like a bunch of Lego bricks. If that function calls a third function, then it makes another stack frame, and so forth. Just pushed above, above, above. And eventually, these function calls finish, and the stack frame is destroyed in a process we call popping. Control goes back to the previous one, then back to the previous one, and so it runs and runs and runs until it's all finished. And this approach means that both function A and function C have their own local variables called counter, but they don't clash. Swift tracks their values independently. Now, synchronous functions have an important downside, which is that they are blocking. If function A here calls function B and needs to know what the return value of the thing actually is, or relies on some work done inside function B, then it must wait for function B to finish before it can continue its work. I know this sounds obvious, but blocking code is problematic because now you've blocked a whole thread. It could be sitting around for a second or more waiting for some data to return. Now, you're probably thinking, look, waiting for a second is nothing at all. But in computing terms, that's an ice age. Like, keep in mind that the neural engine in Apple's M4 CPUs, the newest part here that powers modern Macs these days, is capable of doing 38 trillion things per second. So you block a thread for even a second, that's 38 trillion things you could have done but didn't. Now, one solution to say, well, if we've got a thread that's currently blocked, we should launch a new thread. And that's definitely a solution, but it's also a path towards what's called thread explosion, where the system creates so many threads it becomes a burden. So although synchronous functions are easy to think about and easy to work with, they aren't very efficient for certain kinds of tasks. To make our code more flexible and more efficient, it's possible to create asynchronous functions instead.